about it briefly for one of our classes, but just to refresh your memories. Factorials are the products of whole numbers between 1 and n, which n is like any number in the series, and where n is always positive. So the general equation for factorials are n factorial, which is represented by an exclamation point, equals n times n minus 1. And just to ask, does anyone know what 0 factorial is?
1.
Yay! Okay.
And why is that? Well, this general equation, if you plug in 1, the interesting part is, it will be 1 factor, okay, so I'll write this. 1 factorial equals, I don't have very good handwriting, but 1 times 1 minus 1 factorial, so that's 1 factorial equals 1 times 0 factorial. And that means that 0 factorial equals 1. Yay, moving on. Okay, so there are these weird types of factorials that don't have much relevance in daily life, but I just thought that they were kind of interesting. So the first one, exponential factorials, you can sort of see over here. So basically, you take n, and then it's basically like a factorial, except whenever you go down by a number from n, you just put it as an exponent. So 4 to the third, to the second, to the first, basically. And then factoriums are numbers that each one of its digits, this is really cool, brace yourselves. If you factorial each one of the digits, it becomes a number itself. So 145, 1 factorial plus 4 factorial plus 5 factorial equals 145. And there are only a few of these numbers. And factorial primes, I'm guessing you all know what prime numbers are, seeing as you've been advanced math. So basically there are n factorial minus 1 or n factorial plus 1 occasionally is a prime number. And this is due to the fact that factorials are basically made out of like prime numbers multiplied by each other. So sometimes if you add or subtract a number, then it's no longer a multiple, if you know what I mean. Does everyone understand this? Yeah. So the largest known factorial prime is 34,790 factorial minus 1. And finally, we have superfactorials. And those are basically, the formula for it is n factorial times n minus 1 factorial, etc. So, yeah, you can sort of see how that works there. It's not really useful, but I just thought it looked cool. Also, we have a little review here. Basically, combinations, you have a group of people, for example, and you choose a few of them, and basically order doesn't matter. So here's the equation for combinations. But if you choose some people and they have to be in a specific line, well, okay, basically there's different colors and you have to order them, and there's only one of each color. And yeah, the order does matter. You know this already. So this is just review.
Yeah, and like the reason why like combinations and permutations have to do with factorials is because you use factorials to calculate different combinations or permutations, which is pretty like important if you want to do things in statistics. You're going to be using a lot of combinations, permutations, and factorials. Another thing that that is used, or that factorials are used for, is Pascal's triangle, which is, I believe, we talked about a couple of days ago. I guess I'll just do a little review. It was discovered by a French mathematician and philosopher named Blaise Pascal. And Pascal's triangle can also be used for finding the probabilities of combinations. And here's a little chart here. So if you had like a coin, like heads or tails, like the first combo would be 1 heads, 1 tails, which is 1, 1. And then the second combination you can have is heads, heads, or heads, tails, or tails, heads, or a believe this is tails, tails. And that's another series in Pascal's triangle, 1, 2, 1. And so on and so forth. So how to build a triangle, I guess I'll just zoom through this because we already went over this before a couple days ago. We start with 1, the next number of each row, besides the outer edges, is the sum of the two numbers above it in a triangle format, which is viewed there. So like 1 plus 3 will be 4, and above 3 you can have like 1 plus 2 is 3, and the other outer edges are always 1. And some patterns you can see. You guys know what this is?
Fibonacci.
Yeah, Fibonacci sequence stuff. And then here are some combinations. So you can, if you pick out several numbers from the triangle, you can get several combinations. Sorry. And if you use this equation, you can get any number in Pascal's triangle.
So, are you feeling lucky today? Well, a few days ago, what was it, last Saturday maybe? The Powerball was drawn from. The Powerball is this huge lottery, and the most recent drawing, the jackpot was worth $550 million, is that right?
590.
590, yeah. So basically, someone won $590, of course there's taxes and all that, but there's basically a 175 million chance, because there are 175 million tickets, I think. And I did some research, and basically there is no way to actually increase your chances of getting the winning ticket, even with factorials. But you can prevent yourself from guessing the same number as someone else, because that would cause the jackpot to split. So if you chose, for example, 111 as your jackpot number, and someone else guessed it, and for some reason you won, then both you and the other person would split the 590 million jackpot, and you'd only get half of that. You'd be a poor person. And so
if you want, if you want the full entire prize, then what you would do is you have to guess a number that other people would not guess. So there's a certain series of numbers that are chosen a lot by a lot of people. So if you know what those numbers are and you choose the numbers outside of those, the probability of you not sharing your prize would increase. So.
Couldn't have said it better myself.
Okay, you guys just about finished?
Yep.
Yes, we are done.
Okay. Good.
Thank you.
Questions? I mean,
Questions?
we went over this in class, so hopefully there aren't any questions.
Questions?
We're paying attention.
So there's no real way to increase your chances of winning? No matter how many tickets you buy, you actually won't increase your chances?
Well, I mean, you will actually increase your
He
chances.
means like in
of
terms of
buying
what number
tickets.
you choose.
Oh, okay.
Yeah.
But there's no mathematical formula,
Yeah.
because otherwise the mathematicians would be really rich right now.
Any more questions?
I just wanted to say that something that you touched on, but that you used n factorial. I'm just going to show you this. If we have if we say I say to you, how can you prove that there's an infinite number of prime numbers? Right? There's an infinite number of prime numbers. You'd say, well, you can assume that. I think if I can get this right. Yeah, because if you take a number like, if we assume that there isn't an infinite number, let's assume there's the biggest prime. What is the biggest prime? We'll call it n. Right? If I take all the numbers up to n, and I say n factorial, no matter what n is, it doesn't make any difference, right? And then I add 1 to n factorial to any of the numbers excluding 1, or forget 1, but any of the numbers from n, from 2 up to n. Will they go into n factorial plus 1? No. And that means one of two things. Either, well, actually what it means is that if n is in fact prime, it is not the largest prime, because n factorial plus 1 will have all of these numbers that will not go into this number. So it's either this number is prime, or there's some larger number that's prime. And one way or another, you can use this sort of factorial thing to prove that there's no largest prime number. Sorry that I didn't explain that particularly well. Okay, we'll stop there. Thank you very much, you guys. And we have one more presentation to go.
And do you want me to come for you?
Oh, she's
Oh, fine.